Hello everyone. In this video, I would like to go over the product rule for differentiations. So given function y equal to negative 3 over 7 x squared multiply with this expression square root of 5x cubed minus 6. So obviously we need to use the product rule for this function. So to use the product rule, we need to identify u and v. So you always identify your very first term as u. So this one as u and the second one as v. So the product rule said that we are going to take u multiplied by derivative of v as a function of x, and we add that with v multiplied by derivative of the function used as x, okay, in terms of x. So this is the formulas for the product rule. All right. So the process probably simple. Take derivative of this, then take derivative of this, and substitute it into this equation. However, this question poses a challenge when we have to simplify and express final answer with positive exponent or radicals. So the problem here will be the algebra. Okay, so I will differentiate this first, and then I substitute it into these formulas. And before I simplify and express the final answer with positive exponent, I'm going to review the basic concept of factoring for everyone. All right, so let's start it with this question first. Differentiate this question. So before I differentiate this question, I need to write this expression as the exponent. So I'm going to write it as y equal to negative 3 over 7 x to the exponent 3. And I am going to multiply this with 5x to the exponent 3 minus 6. All of it raised to the exponent a half. So this is the very basic concept first. You need to raise this to the exponent in order to differentiate. Okay, so we are going to identify this as u, and this is v. So then we are going to have u equal to negative 3 over 7 x cubed. Therefore, du over dx will be equal to negative 3 over 7 times 3. Then at the same time, you reduce the exponent by 1. Okay, so what I will do is, because of the simplification process that I have to do next, I'm going to leave this one alone. Okay, I'm not going to take 3 multiplied by 3 here to get negative 9 over 7. I will leave negative 3 over 7 times 3 times x squared. All right, okay. So the next step is to identify the v. So v equal to 5x cubed minus 6, all of it to the exponent a half. Okay, derivative of v as a function of x. Now we are going to apply the chain rule for this because you raise a function to an exponent. Okay, so the first thing you need to do is you take this exponent, you multiply by the coefficient in front of the bracket. In this case, it will be an invisible number 1. All right, okay, so I will have a half times 1, so that is a half. And I rewrite the exact expression. At the same time, I have to take 1 away from this exponent. So a half minus 1 will give me negative a half. Now my next step is I must multiply this with the derivative of the function inside the brackets because I have to apply the chain rule. Okay, so apply the chain rule here. Take derivative of the function inside the bracket. I should have 3 times 5. Okay, so that will be 15 x squared, right? So 15 x squared minus 0, because derivative of 6 is actually 0. So I don't have to write that. So here I have the derivative for v. So now we are going to check, okay, according to these formulas, we need to have u, we need to have dv over dx, we need to have v and du over dx. So we are going to double check. We have that, and that. So all we have to do now is just substitute this into the equation. So now I'm going to write y prime, okay, y prime, or I can write dy over dx, because now you actually apply the process of differentiation. Okay, so the very first thing I have to write is u. Okay, so what I'm going to do is I am going to write it as negative 3 over 7 times x squared. Okay, so I put the product of each term inside the brackets so that later on I can recognize which expression to pull out to make it a factor. Then I have to multiply with dv over dx, which is the entire expression here. So that means I'm going to multiply by a half, and then I multiply by 5x cubed minus 6 raised to exponent negative half. And what I'm going to do is I'm asking you to take a look at 15x squared. So what I'm going to do is I'm going to write 3x squared times 5. All right, so you want to make that into factors, because the concept of common factoring is you have to pull out the factors that is common for both of the expression. Okay, so this is your first expression here. So this one is what? So this one will be my u. Okay, I'm going to label this. This is u, and this is dv over dx. Okay, now I'm adding that with v, which is 5x cubed, okay, minus 6 raised to the exponent a half. And then I multiply by u, which is, du over dx. Okay, so there's du over dx. So du over dx will be negative 3 over 7, and then times 3, and then times x squared. Okay, so let me make sure that I distinguish that is a negative sign. So this will be, this is v, and this is du over dx, to be clear. All right, so the next step is to factor. So factor pose a little bit of a challenge in terms of factoring. So what I'm going to do is I will leave this question for a moment, and I'm going to go to a document where I will review the basic concept of factoring for everyone. Okay, so let's go to a paper, a blank paper. Okay, on here I'm asking everyone to take a look at this. Quick review factoring, concept behind factoring, what is the logic of factoring? Okay, you think that in mind for a second before we start factoring an expression. So what I'm going to do is I'm going to make up an expression which is pretty simple. Okay, so I'm going to make up 5x squared plus 15x cubed. And I will ask you to factor this, okay? All right, so it appears so easy for everyone. So you can do that in just like a split second. You probably tell me right away that, oh, it's 5x squared bracket 1 plus 3x. Okay, so what I'm going to do next is I am going to write it like this. 5x squared. The 15x cubed, I want to pull the common factor out of this. So what do I mean by common factor? Because this 5x squared is actually a factor of 15x cubed. Factors mean multiplication. Okay, so I'm going to write 5x squared times 3x. Okay, so think about this. 5x squared times 3x will give you 15x cubed. All right, so now you are going to factor out the common factor. So factor out the common factors mean that you are going to say right away that it's very easy. So you say this is 1 plus 3x. Okay, so you do this automatically. But then let me ask you this question. I'm going to ask you the why. Why do you have 1 and why do you have that? What do you do in order to have 1 and in order to have 3x? What is the meaning behind factoring? What is the logic of factoring? Okay, so I want to identify and also to emphasize the word logic here. Logic means that whatever you do in mathematics, for an expression, okay, if you divide, then you have to multiply. If you multiply, then you have to divide, because you don't want to change the expressions. All right, so what you basically do is you actually take 5x squared, you multiply with this whole expression. Okay, so I'm going to explain that why for everyone here. Because you are taking 5x squared and you multiply this with the expression of 5x squared plus 15x to the exponent 3. All right, see that? You pull it out of the bracket, it means you multiply. But if you multiply by this, it is an expression. So the concept of factoring, or the logic of factoring, is when you multiply, you need to divide. Then your expression will get back to its original statement. So my original given statement is this. And then I want to multiply this with 5x squared, right? Multiply with 5x squared, it means that you need to divide the whole expression inside the bracket by 5x squared. So what is the algebraic step in here? So what I do is I will write 5x squared divided by 5x squared plus 15x cubed. So don't forget that I said I write 5x squared times 3x, right? Divided by 5x squared. So this is the concept of fractions. Okay, so you need to break this into two fractions if you have a common factors. Okay, a common denominators. So here's a common denominator of 5x squared. I can break that into this fraction. I can break that into this fraction. In the way that if you have a common factor and you pull it out of the brackets, it means that you multiply this with this 5x squared. You must divide the 5x squared into each of this term inside the brackets. Okay, I repeat that. If you pull out common factors, it means you multiply the expression with that factors. So you need to divide your common factor into each of the term inside the brackets. So now you see when you divide each of the term inside the brackets, you end up with, what is it here? So isn't that cancel out, give you 1? And then this one cancel with this, give you 3x. All right, okay. So that is the concept behind the common factor. And the exponents and the whole number for the exponent is easy to recognize. Okay, so then you say, why do I have to go through all the lengthy steps in order to get to this? Because with time, you bypass all of these steps. So these are the important steps. So these are the logic that I try to explain to everyone. Okay, the logic of common factoring is you must take that factor, you divide into each term inside the brackets. Okay, so keep that in mind. So from here to here, you said it's quite obvious. Now I multiply this back inside, I got 5x squared plus 15x cubed. So it's easy to see that. But what about we have like an exponent when it turned into like a half or negative half? So what do we do with that? Okay, so let me give you another example. Okay, another example, and I hope this example will clarify what I'm trying to say. So let's say I have x to the exponent half plus x to the exponent negative half, and I ask you to factor this. Okay, how do you factor this? Okay, so let's go back to this example. You have two expressions, the 5x squared and the x cubed. You factor out the one with the lower number of the exponent. So x squared and x to the exponent 3, 2 is smaller than 3. So you factor out x squared, and in this case 5x squared. Okay, so what you do in this case is you are going to factor out your x to the negative half, because it is the lower exponent. So you always pull out a lower exponent. All right, so then what is the concept that I taught everyone? So x to the exponent a half divided by x to the exponent negative half plus x to the negative half divided by x to the negative half. Okay, so that's the concept that we apply for factoring. So this and that turn out to be just 1. But what about this term? What do I do with this? All right, so I'm going to write this for you here. So this one is 1, so they could be equal to 1 for sure. And then for this particular expression, so this division, what do I do with that? Then we need to remember the another formulas. Okay, the exponent. Concept of exponent. You divide two powers, you need to subtract the two exponents. Okay, so a raised to the exponent m divided by a raised to the exponent n. You keep the same base, but you have to subtract the exponent. So I will do the same for this. So it will be x to the negative half outside the bracket. And here I will have x to the half subtract negative half. Okay, so I will subtract negative half. So that is inside the bracket, and I still have to put plus 1 here, right? Okay, so that was I already found. Okay, so what is a half minus a half? Okay, a half minus negative half. Okay, so that a half plus a half, so it's become 1. So in this case, you could have x to the negative half. In the bracket, you should have x plus 1. So that's how you factor. Okay, with the radical exponent, to factor, you need to apply the concept that you factor out the one that raised to the lower exponent and apply this concept, divide this into each of this term, and then apply the concept of exponent in order to find your final result. Okay, so a lot of algebra, it's called the change of algebra, because in fact algebra is what is the father of calculus. Okay, so without knowing this step in depth, getting to the soul of factoring, then you will understand the complicated questions. Like, take a look at this question. If you understand the logic behind factoring, then you just apply that logic, and then you'll be able to factor this out. Okay, so let me get back to our calculus question. All right, okay, so this is where everyone is asking me questions. How do you factor this? And often we learn very simple factoring in high school or in most classes. we don't work with like radical exponent in terms of factoring or fractional exponent or negative fractional exponent, and then we factor using the logic behind factoring. So it need to apply here. Okay, so now y prime. Okay, so I will show you the common terms. So now you realize why I am writing 3x squared and 5, right? 3x squared and then 5. Okay, you see that? Okay, 3x squared times 5. Because right here, 3 times x squared will be common with that 3x squared. Yeah. Okay, so let me circle circle the one that is common that I'm going to take out the bracket. So first of all, this 2. Okay, so then I will have negative 3 over 7 outside the brackets already. All right, okay, so now the next one I am going to circle for everyone is the 3x squared. So this one is 3x squared. This one is the 3x squared. So this will be my 3x squared. Okay, so what about the rest of it? This x squared, 3x squared, this x squared will have to stay. Okay, u. Okay, I think I better correct it here. This should be an x cubed. Okay, I make an error. Okay, because that is my u. I'm sorry. Okay, so this is my u. Okay, this is my u. Okay, so negative 3 over 7 and x cubed. So I'm sorry, I wrote x squared for no reason. Okay, so it's a sign of getting old. I can tell you that. Even though teaching for 25 years, like I'm entering my 25 years of teaching now, but I think if you get, I think I'm getting old, and I mixed up 2 and 3. Anyway, so the 3x squared is already out of the bracket, right? So x cubed, you don't have any more to over here to make it common. A half stay, and the 5 will have to stay. Now, this expression 5x cubed minus 6 and 5x cubed minus 6, the concept is, how do you factor this? That means you need to pull out the one with the lower exponent. So this one right here and this one right here, right? So I'm going to pull out the one with the lower exponent, which is 5x cubed minus 6 raised to the exponent negative half. Okay, so now what do I have left inside the bracket? Inside the bracket, you left with still with this term. Okay, so I just need to find another pen. Okay, so here, this you left with that, you left with that, and then you left with the 5. All right, okay, so that means you will have x cubed, you will have a half, and you will have 5. Okay, and what about this one? This one right here. Okay, okay, so that means you are going to have the a half subtract negative half, as I explained in this example. So in this example, what I have done is I asked everyone to take this half minus this negative half according to this exponent, and it will turn into a 1. Okay, the expression to exponent 1. So we went back to our question. Then I should have, excuse me, okay, 5x cubed minus 6 raised to the exponent 1. Okay, so do we write raised to exponent 1? We don't. The 1 is invisible. Therefore, I am going to erase that one. Okay, so the next step is to, again, simplify. So to simplify, I will do this. Okay, so I will write this one as negative 3 times 3 will give me negative 9. Okay, so negative 9 x squared over 7. And I leave this one here for now. I will make that into positive exponent at the very last step. Okay, so now inside this bracket, because of the half, everyone is going to ask me questions. Why I combine, how do you add this? Okay, so what you need to do is you are going to multiply this first. So I should have 5x cubed over 2 plus 5x cubed minus 6. Okay, so you can take the brackets away now because that raised just to exponent 1. So I'm going to simplify what inside this bracket. Okay, so we are going to simplify this. Okay, simplify this. I should do this. Okay, so let's rewrite what we have outside the bracket. Okay, so that negative half. Okay, now to add or subtract fraction, we need to have a common denominator. So the common denominator here should be 2. Okay, so I have 5x cubed divided by 2. So I hope these are all basic algebra that we need to remember, and we need to have the knowledge before we can do calculus. So if you struggle with this, you really have to go back and review the algebra. So but I do step by step here. So if I have that as 2, that means I must multiply this by 2, so that I end up with 10x to the exponent 3. If I make this a common denominator of 2, then I must multiply 6 by 2, so I will have 12. Okay, so then I will write this as negative 9x over 7, 5x cubed minus 6 to negative half. Okay, so this will be 5x cubed plus 10x cubed, subtract 12, everything over 2. That is the purpose of having common factor, because now you can combine the like term of the numerators. So combine like term of the numerators, you see, you can have this term and this term that you can combine. And at the same time, I'm going to bring this down to the denominator and make that into a positive exponent. Okay, so y prime equal negative 9x squared, 7, 5x cubed, subtract 6, raised to exponent positive half this time. And inside the bracket, I should have 15 x cubed, subtract 12 divided by 2. Okay, so this and this combine, giving me 15x cubed. And basically, here is what happened. X cubed minus 6 to the half. This I can take out the half. Okay, and inside the bracket, what I have is, if you already take out the half, inside the bracket you should that with 15x cubed minus 12. But there's a common factor between these two. Okay, so common factor between these two. So therefore, if I factor that, it will be 3 5x cubed minus 4. Okay, then you can take the 3 out and multiply with the negative 9. Okay, therefore I am having y prime as negative 27x squared, 5x cubed minus 4, and down I have 14, 5x cubed minus 6 raised to the half. this time that give me 14. All right, okay.